These are proofs for the derivatives of generalized exponentials and logarithms. That is, the derivative of b to the x rather than e to the x, and the derivative of log base b of x instead of just natural log of x. To get the derivative of b to the x, we're going to use the logarithmic identity that b can be thought to be e to the natural log of b, because after all, the natural log of b is the power that we raise e to get b. Therefore, b to the x is e to the log b to the x. And then using the laws of exponents, we know that the power of a power, we can just multiply them together. So this is e to the x log b. So now we can basically do a chain rule. We have dx of b to the x, which is dx of e to the x log b, which is the derivative of e to the something, where the something is a function of x. So this is going to be a chain rule. The derivative of e to the something is just e to the something times the natural log of the something. Here our something is x log b. Log of b is a constant, so when I take a derivative of a constant times x, I get just the constant. And so what comes out is just natural log b. And finally, we say, wait a minute, e to the x log b was just b to the x. So we end up with b to the x natural log b. In other words, the exponential reproduces itself just like the e to the x did, but we also pick up this conversion factor log of b. That's in fact why the natural base is the natural base. It's the one in which the conversion factor happens to be 1. In getting the derivative of the generalized logarithm, we're going to have to basically somehow get this to look like natural log of x. Just like before, those are the only ones I know, so I want to make this look something like it. But I know that from the change of base formula that really log base b of x is just some scale factor of natural log of x. So we'll just rederive the change of base formula so as to be able to use it. So we say, oh, if I have something which is log base b to the x, and then I raise b to both sides, so I have b to the y is b to the log base b of x, and then I use the definition, b to the log base b of x. Well, log base b of x is the number that when b is raised to that number, I get x. And if I raise b to the number that when b is raised to this number, I get x, what should come out should be just x. All right, very roundabout way of saying, if y equals log base b of x, then x equals b to the y. And now I'm going to take the natural log of both sides. So I have the natural log of b to the y is the natural log of x. And the reason for doing that in large point is to say that now I have log of a power, and I know that I can bring the power out front. So I'll have y natural log of b is the natural log of x. And finally, I can solve over for y, and I can say y is the natural log of x over the natural log of b. But remember that y was just log base b of x. So log base b of x is the natural log of x over the natural log of b. This is what's called the change of base formula, right? Because we have changed from base b to base e. It actually works from changing from any one base to any other base, but right now it's going to be practical to do for this one. Now we can see that our desired derivative, the derivative of the log base b of x, is the same as the derivative with respect to x of the fraction natural log x over natural log b. B is a base, it's definitely a constant in this context, and so log of b is a constant, and therefore 1 over log of b is a constant, and all of that combines to say that we can take that constant out front, and we'll have 1 over log b, and we'll be left with d dx of the natural log of x. But the natural log of x is pretty easy. The derivative of that is just 1 over x, so I end up with 1 over the natural log of b times 1 over x. This is more traditionally written, but not importantly, as 1 over, and it's usually written as x log b. So we've ended up with two new generalized derivative rules. one of which is that the derivative with respect to x of b to the x is just b to the x times the natural log of b. And the other is that the derivative with respect to x of the log base b of x is just 1 over x log of b. In both cases, natural log. And we might see that basically the log b has attached to whatever comes out of the original derivative for the base e stuff, which is one way, I suppose, to remember it. Either way, this allows us to take the derivative of exponentials of any base or logarithms of any base.